This is 8.1, Symbols and Sets of Real Numbers. We're going to talk about the different types of numbers on the number line. And I'm sure you've all seen a number line before. Here is what a number line looks like. And we usually see numbers written at the different marks on the number line. So we would have 0. And if we go to the right, the numbers get bigger. 1, 2, 3, 4, 5, 6, and so on. And if we go to the left, the numbers get bigger, but they're negative. So -1, -2, -3, and so on. So all of these numbers that we see and all of the numbers in between those numbers are called real numbers. So the definition of real numbers is all the numbers on the number line. Now let's break those down into categories. We can break up the real numbers into different sets or categories. And the first set that we're going to talk about is the numbers 1, 2, 3. So these whole numbers, we're going to keep going bigger and bigger. Well, to the right. So we start with 1 and we get bigger. Okay, those are called natural numbers. Another term that is used for natural numbers is counting numbers, because when we count, we don't start with 0. If we're going to start counting things, we start with the number 1. So natural numbers or counting numbers are the numbers 1 and greater that are whole numbers. That's our first set of numbers in our real numbers. The next set gets a little bit bigger. So it takes all of these numbers that are already in the natural number set and it just adds a 0. Okay, so if we have 0 plus all of the numbers that we had before, those are called whole numbers. So the way that I remember that, whole, O, 0, it adds 0. Whole numbers add 0. So now if we take those numbers and we get a little bit bigger, all right, so if we start with 0 and go 1, 2, 3, 4 to a million, a billion, keep on going, what else is left? Well, we didn't go to the left. We didn't take up the negative numbers. So that's what we need to add now, are the negative whole numbers. So if I start at the left at negative infinity and I get up close to 0, I'm going to have -3, -2, -1, 0, and all the numbers we've already talked about. Those are called integers. All right. So every time it includes the things before it, and it just gets a little bit bigger. Oof, my circle is not very pretty. Let me try that again. All right, it's a little bit better. Okay, so now you may say, well, what's left? We've already named all of the numbers. Well, remember it's all of those numbers plus all of the things that are in between. Well, what would be in between these numbers? Fractions or decimals, right? Okay, so if we were to say things like -3 and 1/3, or -1.5, or we could say 2/3, or 7.25. All of those things, all of those decimals or fractions would be in this next category, plus all of the stuff before. So these are called rational numbers, and the actual word definition of rational numbers are any numbers that can be rewritten as fractions. Okay, so we know that decimals can be written as fractions, and then we have some fractions in here, of course, that are written as fractions. But what about these other numbers? Say if I were to take the number 5. Could I rewrite 5 as a fraction? Yes, I can rewrite any whole number as a fraction by putting it over 1. So that's why all of these numbers are still included, because they can be written as fractions, plus all the fractions and decimals that are in between are called rational numbers. Now, there's one more category that falls under the umbrella of real numbers, and those are called irrational numbers. So the irrational numbers, we say they're a little bit crazy. They're all off by themselves. They don't want to follow the rules. So irrational numbers, since rational numbers, all of these are can also be rational numbers. That means they can all be written as fractions. So irrational numbers are numbers that cannot be written as fractions. And some examples of those would be decimals that don't stop and that don't repeat. So if we had 0.2759, and then it keeps going, and the way that we show it keeps going is to put those dots behind it, those 3 dots behind it, the ellipses behind it. So that would be an irrational number. A common irrational number that people know of is pi. Pi is 3.14159265358979323, and it keeps going, and it doesn't stop, and it doesn't repeat. So that's an irrational number. Another irrational number would be any radical, a square root, that is not a perfect square. So we know that, for example, the square root of 4 equals 2, right? That's a perfect square. Okay, that's not what I'm talking about. If it's something that's not a perfect square, like the square root of 2, there's no number we can multiply by itself to get 2, so it's not a perfect square. That would be an irrational number. If you were to put that in your calculator, square root of 2, you would get a bunch of decimals that go to the end of your screen. So any number that cannot be written as a fraction, or if we see it written out as a decimal, it doesn't stop and it doesn't repeat, that's an irrational number. And all of these fall under the umbrella of a real number. Okay, so a real number, you might say, well, aren't all numbers real numbers? We actually have numbers that are called complex numbers or imaginary numbers, but we don't talk about that in this course. It will be discussed once you get to college algebra. So for now, we're dealing with all real numbers. Now, I wanted you to see visually about the different categories or the different sets of numbers. Let's go back over the definitions of those numbers. Natural numbers, they're also called counting numbers, and they start with 1 and continue going up as whole numbers in the positive direction. So 1, 2, 3, 4, 5, those are all natural numbers. Whole numbers include those numbers, but it also adds 0. Whole, 0. Integers are any positive or negative whole numbers plus 0. Rational numbers are any numbers that can be rewritten as fractions. And irrational numbers are numbers that cannot be rewritten as fractions. Okay, so let's practice putting these different numbers in the sets in which they belong. Okay, so which set or sets does the number 0 belong to? Well, we know it doesn't belong to natural numbers because natural numbers start with 1. But 0 is a whole number. 0 is also an integer. Remember, integers are positive or negative whole numbers plus 0. And then it's also a rational number. I'm going to put not just an R because you might think that that stands for real. Okay, so then for B, oh, well, let me also put IN for integer because that could also mean irrational. Okay, so integer and rational. All right, so then for B, we have a fraction. Could that be a natural number? No. What about a whole number? No. What about an integer? No. What about rational? Yes, remember rationals are any numbers that can be written as a fraction. Okay, what about pi? Remember, pi is an irrational number. All right, this one's a little tricky. This is a decimal and then 3 with a bar on top. You know what that bar on top means? That means that it keeps going. So this would be like, if I were to keep writing it, we would have 3, 3, 3, 3, and that didn't look like a 3, and it keeps repeating. Okay, so remember I said if it repeats, then it's a rational number. An irrational number is a number that doesn't stop and it doesn't repeat. Okay, so this is irrational. I mean, this is rational. All right, what about for E? Well, this means that it keeps going, so it doesn't stop and it doesn't look like it's repeating. So this would be an irrational number. Okay, -8. Would it be natural? No, natural are just positive numbers. What about whole? No, whole are the natural numbers plus 0. What about integers? Yes, integers are positive or negative whole numbers. And then it would also be a rational number because we could rewrite it as a fraction just by putting it over 1. So that would be a rational number. So if you think about our sets, like how we had them written in this chart, if it falls in a category, say if it's an integer, just like we had -8, it's going to be that plus anything greater than that. Okay, so say if we said 0, the first place 0 appeared was a whole number, but it's whole numbers, integers, and rational numbers. So it's going to be that category or that set plus anything bigger than that set. Okay, let's try the next one. All right, this one's a little messed up. Let me see if I can fix this. No, okay. So this is supposed to be 25 over 5. So 25 over 5. What kind of number is that? Would it be a natural number? Well, what is 25 over 5? That would be 5, right? So it would be a natural number. Okay, so it's natural. Would it be a whole number? Yes. Would it be an integer? Yes. What about a rational number? Well, it started out as a fraction, so of course it can be rewritten as a fraction, so it's also rational. Integer and rational. Okay, so then for H, we have the square root of 8. Is the square root of 8 a perfect square? Well, remember, a perfect square is any number that that we can get by multiplying another number times itself. So if I multiply 2 times 2, I get 4. Or if I multiply 3 times 3, I get 9. Okay, so there's no number that I can multiply times itself to get 8. So it is not a perfect square, so that means this would be an irrational number. Okay, so if you see a fraction like this one, always simplify it first before you determine what sets it belongs to. In the same way, if we have a radical, see if you can simplify it first and then see what sets it goes into. Well, we can't simplify 8, it's not a perfect square, but 36, what is the square root of 36? The square root of 36 is 6. Okay, so now that I've simplified it, I can tell what sets it belongs to. It's a natural number, a whole number, an integer, and a rational number. Okay, and then for J, we have 2.135135, and it keeps going. Okay, we see that it keeps going, but it is repeating 135, 135, 135. And so if it's repeating, then it is a rational number. Remember, irrational doesn't stop and it doesn't repeat. Okay, some symbols that you need to be familiar with in math are these symbols here. We know that this is equals. This is greater than. This is greater than or equal to if it has that line underneath it. Less than or equal to. Okay, so for these symbols, sometimes students get confused about which ones mean less than and which ones mean greater than. Well, for the less than symbol, you know, it's like this. Well, if you turn it just a little bit, it makes an L for less than. Okay, so then we know the other one is greater than. Okay, this is not equal to when we see an equal sign with a slash through it. This is our square root symbol. If we see two bars next to each other, that's absolute value. Parentheses and brackets both can either group things together, or if things are inside of that and we have something outside of that, then they're being multiplied. So now